Hello everyone and welcome to this coding session. So today we are going to correct the neural style transfer project. Okay, so I'm going to code only the 5 first tasks so that you can finish the rest by yourself. But if you find that I should code the rest of the tasks, I will just send me a message and I will record another video on how to code the rest of the tasks, okay? Okay, so as you already know, the neural style transfer is a method where we use a content image and a style image, and we want to transfer the style of this image in the content image. So the result will be like this. Okay, so we guard the shape of this image and we add the colors and the texture of this image, and we get this one. Okay, so let's start with the first task. So the images that we are going to work with are this content image, and this for the style image. Okay, so the first task is to create a class NST that performs tasks for the neural style transfer. Okay, so before we begin, we have to just change the version of TensorFlow, because you need in this project to use TensorFlow the version 1.x. So TensorFlow version, I'm going to set it to 1.x. Okay. The second thing required in this project is to use the eager execution of TensorFlow. Okay, so I'm going to activate the eager execution, but for those who don't know what it is, the eager execution, or why we are using it, in fact it is a powerful execution environment that evaluates operation immediately. So it does not build graphs, and the operations will return actual values. Okay, so instead of computational graph, they will send the actual values of your calculation. Okay, so with eager execution, TensorFlow calculates the values of the tensors as they occur in your code. Okay, so for TensorFlow, the version 2, the eager execution is by default, but for this version we need to enable it. Okay, so let's first import TensorFlow as TF, and then we enable the execution. So you can do this inside the class, but I prefer to do it outside, so I can work with it for the rest of the tasks. Okay, so we have enabled our execution, our eager execution, and now let's start our class, which is called NST, or I think it is NST. Okay, so let's start. What we have here, so we have the public class attributes, the style layers. So we have these list of layers that we are going to use, or to use their outputs as our style features. Okay, and we have the content layer, which is a unique layer to extract the feature for the content image. Okay, so I'm going to just take these as they are. Okay, so as the article or the original paper said, we are to product the results from this paper. Okay, so this paper they use by choice or by experience. They experience several layers for the style layers and the content layers, and they found that these layers for the style features to extract the style features, and this layer to extract the content features, they gave the best results. Okay. Okay, so this is for the public attributes. Now we have the class constructor. Okay, so we have the style image, the content image, our alpha and beta, which are the weights of the content loss and the style loss. Okay. So what does this function need? Okay, so we have the style image, which is the image used as a style reference stored as an NumPy, sorry, and the content image is the image used as a content reference and stored as a NumPy. Also, we have the alpha and beta, the weights of the content loss and the style loss. Okay, so first of all, we have some. We should make sure that we have a NumPy for both style and content image, and we have a specific shape. Okay, so the shape has to be with 3 dimensions, and the third dimension, which is the depth of the image, should be 3. Okay, so for the RGB colors. Okay. Okay, so let's start with these errors. Okay, so let's start with the type. If type of the style image is not or if the style okay, or if the dimension, sorry, so ng here to refers to the number of dimensions that we have, so it is different of 3, and or the style image, the third dimension of the style image isn't 3. Okay, so the style image dot shape, the second, so we need the third, or if you start with the 0, we should have the second dimensions equals to 3. Okay, so this is what we should have. So if you don't have these, we should raise the type error so the type error should be the style image must be an NP array and with shape this shape. Okay, so the content image will have the same thing. Okay, so we have to change it for the content image. So this is for the style image and content image. Now we have the alpha. So if alpha is not a non-negative number, we should raise a type error. Okay, so alpha should be a non-negative number. So if not, if the type of alpha is not int or float. Okay, so if it is not int and the type of alpha isn't. So this is the first condition. Okay. Okay, so I'm just going to do this. Okay, and the second one, it shouldn't be negative. Okay, so or alpha, which says alpha must be a non-negative number. Okay, this is for alpha. I think beta is the same thing. Beta must be a non-negative number. Okay, so this is for the errors. I think that's it for the errors. Okay. Okay, so we should set TensorFlow to execute eagerly. That's what we already did. And then we should set the instance attribute. Okay, so we should set the style image, which is the pre-processed style image. So it's not the style image that we have here. We should pre-process it. The content image also should be pre-processed. Alpha and beta are the weight for the content cost and the weight for the style cost. Okay, so we won't change alpha and beta, but we should pre-process these two images. Okay, so we have our state methods that will pre-process our image. Okay, so this is called the scale image that will take the image. So I'm going to. Okay, now let's say that our image, sorry, our style image, or sorry, self dot style image is equal to self dot scale image of the style image that we have. Okay, and the same thing for the content image. Okay. Now, okay, and we have the self and the self beta is equal to beta. Okay, so the easy part is done. Now we should code our scale image function. Okay. Okay, so it is static methods. Okay, that will rescale an image such that its pixels value are between 0 and 1. Okay, so we have to put our pixels value between 0 and 1, and its largest site is 512. Okay. Okay, so our image is a NumPy array with shape hash WM3 containing the image to be scaled. Okay, so we have an error to raise here if the image is not a NumPy array with the shape hash W3, we should raise an error. Okay, so we should basically do the same thing as we did here. Okay. Okay, so if the type of the image isn't NP ND array, or the content or the image, the number of dimension of the image isn't 3, or the content or the image, the second dimension of the image isn't 3, so we should raise the error. The image must be an NP array with shape. Okay, so let's say that HW, and we don't care about the third dimension, equals to image dot shape. Okay, we want the maximum dimension equals to 512. Okay, so for example, let's say that we have an image with, for example, the height equals to 200 and the width to 100. Okay, for example, so we have okay, so we should rescale this image and reshape it until the maximum between 200 and 100, which is 200, should be 512. Okay, so let's say that for example, that my maximum is the max between H and W. Okay, and let's say that our scale, how much we want to enlarge our image. Okay, so the scale will be our max dimension that we want divided by the maximum. Okay, so for example, if we have here our maximum is 200 and the max dimension is 512, so our scale will be 512 divided by 200, which is 2.56. Okay, so we want to enlarge our image with the scale of 2, let's say 2.5. Okay, so if we want our height to be 512, we want to enlarge our weight with the same scale that we did for the height. Okay, so our new shape will be the H multiplied by our max dimension, by our scale. Okay, so we have 200 multiplied by this scale, so we can have 512. Okay, and our new weight will be large with the same scale. Okay, so it will be our W multiplied by our scale. Okay, so it will be 100 multiplied by 2.2.56. Okay, so it will be 256. Okay, so let's make sure that these are integers. Okay, so our new shape that we want is this is our new height, this is our new weight. Okay, so here an example with the height is bigger than the weight, but it can be the opposite. Okay, so we just take the max between these two and we just divide or calculate our scale like our max dimension divided by the maximum between these two, and then we multiply our two first shapes with our scale. Okay, so this is what is meant by this sentence. Okay. Okay, so now we want it to be a tensor with shape 1 and our new shape and tree. Okay, so first of all, I'm going to add a dimension to my image, my first image. Okay, so I'm just going to say that image is numpy dot expand dimension. Okay, so expand dimension, I'm going to add to my image as the axis 0. Okay, so I'm going to just add this one here. Okay, okay, so the next step is to use my new the TensorFlow so that we can get the tensor. So I'm just going to call it the scaled image. So we can now resize our image using the functions from TensorFlow. Okay, so we can get a TensorFlow, but here in your project, in this task, it says that the resize should be using the bicubic interpolation. Okay, so we're just going to use this with the function from image. So TensorFlow dot image dot resize bicubic. Okay, okay, so this one should have the image and then the size that the new size that we want, which is our new shape. Okay, so in this argument it should be only the height and the weight. Okay, so it's expected 1 or 2 values. Okay, so we can just put all these dimensions together. Okay, so if you just put the image which already have the expand dimension, the first dimension here, the function from TensorFlow, it will resize all these shape by only updating these two shapes. Okay, so this is what the resize bicubic does from TensorFlow. Okay, okay, so this is for the resizing. Now we have to rescale the image. So after resizing, the image pixel value should be rescaled from the range 0 to 55 to 01. Okay, so first of all we should okay, so I'm going to call it rescaled image once again. So okay, so there is a function that we are going to use that will for all the values in this image will just rescale it, or yes, it will just rescale it after we divide it by 255. It will take the minimum value for each pixel as 0 and the maximum is 1. So this is called the TensorFlow dot clip by value. Okay, okay, so it will take our image okay, so first of all I'm going to divide this by 255. Okay, but I'm not sure that if I divide my pixels by 255, I will get the values between 0 or and 1, because in some images the value is, for example, is a negative number, or between, for example, minus 300 and plus 300, etc. Okay, so it's not always between 0 and 255. Okay, so after dividing my number, I will set my okay, so here clip by value will take our t, which is the tensor that I want to scale, and then we'll take the clip value minimum, so the minimum value that I want, which is 0, and then the maximum value that I want, which is 1. Okay, okay, so this is all for this function. I will just return my scaled image. Okay, Okay, now this is all for the scaled image. I'm going to try this. I'm going to get the main here. Okay, so I already load these two images here. Okay. Okay, so let's just run this. Okay. So these are the results that I get. So first of all, I will print the style layers. These are the style layers that I'm going to use to capture my style from the image. This is my content image. Okay, after this, I'm going to print the type of the style image, which is a tensor with this shape here. Okay, so this is the shape that I have. The maximum shape is 512, just like he wanted to be. Okay, so the maximum value here is with the weight. Okay, so this is the maximum value. Okay, so and then I'm going to just show my two images. Okay, so this is my style image and this is my content image that are scaled. Okay. Okay, so this is all for the first tasks. Let us move to the second one. Okay, so these are the same results that you want. Okay, so the second task will be to load the model, because in this in the neural style transfer we use a pre-trained model, okay, to facilitate our work and to get more or better results. Okay, so for this one, for the original paper, they used the VGG19, and this is what we are going to do here. Okay, so we are going to update the class constructor. What we are going to add, we are just going to add our model. Okay, so it is the Keras model used to calculate the cost. Okay, okay, so and then we are going to add our def load model. Okay, so just I'm going to copy this. And I'm going to add here our methods, self.load model. And then I'm going to define this function. So it's a public function, a public method, def load model. Okay. So what it does exactly? Okay, so it is the model should use the VGG19 from Keras model as a base. Okay, so I'm going to import this. I'm going to call this pre-trained model VGG. So TensorFlow.keras.applications.VGG19. So this one we won't include the top. Okay. Okay, this is our pre-trained model that we need to calculate the cost. After this, we are going to okay, so after this, the model's output. Okay, the model's input should be the same as the VGG19 input, so I'm just going to call x equals to VGG dot input. Okay, and then I'm going to call my model equals to tf dot keras dot models dot model is going to take my VGG input, okay, and then it's going to take also the output that I'm going to construct. Okay, and then after this I'm going to just call it with the self. Okay, so what we should do now is to construct our output. Okay, so we have two outputs, the outputs for the style layers, and it is followed by the output of the content layer. Okay, so I'm just going to call my style outputs as a list, okay, and my style, my content output as none. Okay, so these are the outputs that I want. Now what we should do is just to do a loop over the layers. Okay, and if we found the name of the style layers, okay, so if the layer dot name is equals in our first our first list, okay, in the style layers, I just going to call it self dot style layers. Okay, so if you found the name of this layer in our list of the style layers, what we are going to do is to, sorry, here I should put this. If we found it, we should take the output and add it to my list. Okay, so style output add append, sorry, my layer. Okay, so if you find the name of the layer is one of these names, in this case I need it in my output. Okay, sorry, I need the output of the layer. Okay, this is what he wants. Okay, he wants to the outputs of the layers listed in the style layers, followed by the content layer. Okay, and we are going to do the same thing for the content layer. If layer dot name in self, or not in equals because there is just one name, self dot content layer. So in this case I'm going to my content output is going to be the output of this layer. Okay, is going to be the layer dot output. Okay, so after this okay, so I should put my my layers as non-trainable. Okay, so I don't want to train my model. Okay, so layer dot trainable is false. Okay, so this is what I get. Now what remains is to put all these in a list all together and call it the outputs. So my outputs will be my style output at first, and then I will add it a list that will contain my content output. So here I'm adding two lists, the elements of the two lists. So I have my final output, okay, and then I'm going to fit my model, or I'm going to construct my model with the VGG input and the output, okay. Okay, okay, so now I'm going to run this and to try the main. Okay, I know that you are already, if you already done this task, you will say there's something missing, but I just wanted to know. Okay, so this is what I get. Okay, so let's see what I supposed to have. Okay, it seems all good except that in this layer we have here an average pooling layer, and here it is a max pooling layer. Okay, so why is this so? Because in this original paper, in the part of methods, okay, it says that okay, so it says that they found that replacing the max pooling operation by average pooling improves the gradient flow, and one obtains slightly more appealing results. Okay, so after the experience, they get that changing the max pooling layer with the average pooling layer will be more efficient for this project, okay, for this problem. Okay, so now we should try to how to replace the max pooling layer in our pre-trained model with the average pooling layer. Okay, so if you Google it, it will be easy because there is several ways to do this. We are just going to try one now. Okay. Okay, so in our loop, we are going to loop over, or to find, we should find the max pooling layer. Okay, so how we should do this? Okay, if our layer is instance of the max pooling layer, okay, if is instance, okay, so this is one way to do it. Okay, there is several other ways. If is instance layer is so if the layer is instance of tf.keras.layers.max pooling. Okay, so if my layer is a max pooling layer, what should I do in this case? I should replace this one with the average pooling layer. Okay, so my layer will be tf.keras.layers.average pooling layer. Okay, so what this average pooling should have as pool size, as strides, as padding, etc. So it will have the exact same arguments or strides or values as the max pooling layer. Okay, so I'm just going to put my pool size is equals to the layer pool size. Okay, my strides equals to my layer dot strides. Okay, my padding also is equals to my layer padding. Okay, okay, even the name of the layer. Okay, so when I say the name of the layer, I mean this. Okay, so for example, the block 1 pool. Okay, so I want it to be the same. So I'm just going to put name equals to layer dot name. Okay, So this is where I change my max pooling layer with an average pooling layer. Okay. If he found the max pooling layer, what should he do is that he give this layer. For example, let's say that we have here x is my input. Okay, so my new x will be this layer with or as argument my previous layer. Okay, so my new x is the output of this layer. Okay, so here we have as output my x, and then if I found that I have a max pooling layer, my new x will be the output of this x. Okay, and this I'm still in this loop. As we have our layer will be the output of the other layer, okay, of the previous layer. If layer name is self point layers, our outputs will append the output of this layer, which is x. Okay, and if the layer name is the self content layer, so our content output will be the layer output or x. Okay. Okay, and then the layer won't be trainable. Okay. Okay, so now the rest will be the same, except that we won't include the input layer. Okay, so we don't need the input layer to be in this loop, because we already have our x as input here. Okay, otherwise it will be two times. Okay, so we will start from the first layer. Okay, not the 0, the first one. Okay, so let's try this. Okay, so now we have our average pooling layer, and it all seems to be good.